What is a true black body? So a true black body is which is 100% pure black in color. So our hair is not 100% pure black. It's just a black, but not 100% pure black. So in this universe, there are only two bodies which are 100% pure black. So we can call it as a true black color. So that is one which is present in our eye. So that is the pupil. The pupil, the black color part which is present in our eyeball, so it is 100% pure black color. So it absorbs the light which is present in our surrounding and it absorbs the light inside it. And the second thing is the black hole. Yes, the black hole is also 100% pure black. But actually, what is a black hole? So black hole is a hole which is in black in color. Is it true? No. So it's just like a star, a burning star with an empty body, and it absorbs the radiation inside it. Now in today's episode, we will discuss about a black hole and what are the different parts of the black hole in it. Now what are you waiting for? Welcome to our channel Physics for AP version 2.0 and let us discuss about the black hole. So today's episode is the black hole and we will discuss about the gravitational waves. A black hole is a region of space-time where gravity is so strong and nothing, no particle or even electromagnetic radiation such as light can escape from it. So even the massive planets or any other asteroids, so any other particle which moves in front of it, it just really sucks into it. Now how are these formed? Before that, let us know about the life cycle of a star. So if a star is equals to the mass of the sun which we have, it won't form the black hole. But if the star is really massive, that means 1.4 times of our sun or even more than that, then due to the nuclear fusion, it becomes a red supergiant and then a huge explosion occurs which is called a supernova and it may form a neutron star or a black hole. The hydrogen atoms present at the sun core combines together to form a helium atom with releasing of amount of energy. So this radiation emits out as well as the gravity pulls the radiation inwards. So as the radiation and gravity are both balanced each other here. So here we have a virtual animation. So these hydrogen atoms, they combine together to form the helium and they release more amount of energy outside, but the star's gravitation, they pull on the radiation inwards and this makes the sun stable. So the radiation which comes out and the gravitation pulls it down back again. So the continuous nuclear fusion makes upon the heavier elements here and they go up to the formation of iron at the center of the sun's core. So form iron, silicon, oxygen, neon, carbon. So more number of elements are present over here, but when the iron becomes more, so the radiation becomes less and the gravity becomes more enough. So as there is more attraction force, so what happened here, the whole radiation, the elements, the particles are being attracted towards the center of the sun's core and just moves on a blast which we call it as the supernova. So after this, if the star is massive, it may become as a neutron star, or if it is more massive, then it becomes a black hole. So that is how the black hole has been formed. So the black holes, anything which moves in front just sucks inside it. Any point in the space has a return, but near to the black hole there is no return once it is been get in, so it acts as an evil. So here we have a point which we call it as the event horizon. So this is the point of no return. So any object, even the light that is within its radius, cannot escape the gravitational pull of the black hole. So if you want to escape, you need to travel with more than the speed of the light, but it's impossible. So the speed of the light is 3 lakhs kilometers per second. The black colored part of the black hole is called the event horizon. But what is at the center of the black hole? So it is called the singularity. So this is the region of the black hole where all the mass of the black hole has been compressed down to nearly zero volume with infinite density. As a result, the singularity has almost infinite density and creates an enormous gravitational force. Let us consider the space as a fabric. Now, if you put any heavier object upon it, it bends down. So not only even the planet, the sun, any other heavier objects, when it is kept upon the space fabric, it is been bent out due to the heavier mass of it. So the same as the black hole, as it has very extreme mass, and the singularity, you can see it is pointing very downward. So if you see the picture over here, the sun, which has a lower singularity, which is very less, the white dwarf, the neutron star, and when you see compare with all others, when you see the for the black hole, so the black hole has very thin enormous which we call the singularity, with zero volume and zero surface, but with high density and more gravitation force is been concentrated upon that area, which we call it as the singularity. So any massive objects has a singularity, but the black hole has the enormous singularity with enormous attraction force. So the photon sphere and accretion disk. So accretion disk is the disk composed of stellar materials that is spiraling towards that black hole. And the photon sphere, it is the non-rotating black hole, that is the surface non-rotating black hole. So here you can see from the interstellar movie, which is rotating upon it, the photon sphere. So here the light can be escaped, but it cannot move into the black hole, so it can be escaped out. So the photon sphere is a spherical region of space that has a gravity strong enough to force photons to travel in orbits. If you were to stand in this region and look straight ahead, you would see back of your head. So photon sphere is where the light can be bent out. So if you stand at one point, so you can see your head backside. Why? Because the light is been bending out. The ergosphere, which is another part of the black hole. So before that, we will see the singularity in the three-dimensional form, where it is a single point. So it is also called as the ringularity, where the thickness is zero with infinite density and it rotates out with high speed. So the ergosphere is the outer layer of the event horizon. So it could be said as, if the black hole is rotating, then as it spins, its mass causes the space-time around the black hole to rotate as well. So here, when you compare with the ergosphere, there is a time dilation in the event horizon, but you might not feel any difference in the ergosphere. But once if you enter into the ergosphere, you can easily come out. But if you enter into the event horizon, it's impossible to get out from the event horizon. Now let us see a clip from the interstellar movie. So the Cooper moves into the black hole. So let us see the clipping of that movie.
Okay, I'm nosing down. Approaching the event horizon. Port side, dipping down beneath it to go through it. Heading towards blackness. It's all black. Tars, do you read me? It's all blackness. Tars, do you read me? Over. screens. Getting interference. Losing control of the stick. Got flashes. Flashes of lightness, blackness. Turbulence in the gravity. It's increasing. Computer's going down. Gravitational pull, I'm losing control of the stick.
So you have seen Cooper had went into the black hole and entered into the another dimension field. But is it true that could we survive when we go into the black hole? But once when we enter into the singularity, our body gets stretches out due to the gravitation field. Our sun is also a star. So can it form a black hole? No. So our sun cannot form a black hole, but if it form a black hole, then what is the consequences of it? Let's see with an example. For example, if our sun in our solar system becomes a black hole, so it cannot suck everything like a vacuum cleaner, but it makes the earth freeze. Now suppose if you are falling down into the black hole, so there is a difference of time, that means the time is relative. So the time goes very slower, very slow and very slow, that it can be you can feel that by sitting in the black hole, so the hundreds of years will be passed up in front of you, but your age still will be very slow, but the time moves on fast. But what actually really happens when you move into the black hole? It's very simple, just it's a singularity, so it's just only a one way, just like playing a video game. Once you move forward, you cannot come backward, just like the Mario game when you play. So what happened here, it stretches your body, then your skin, your muscles, and finally the bones are also being stretched away. So simply what we can see is all the cells which are present in our body are being stretched out due to the strong gravitation field, and once you'll be died. Or in the second way, once here we can, if we enter into the black hole, you will be hit to the firewall and become an ash. So the death zones here, for a small black hole, the outer region is the death zone, but for a massive black hole, the death zone will be at the present of the singularity. So it is better to be stay away from the singularity. The theoretical physicist Dr. Stephen Hawking had provided the Hawking radiation equation in the year 1974, which is the entropy of the Hawking's radiation. For example, if we consider a black hole and having a radiation which emits in outward direction. Now if we take an empty space, so here we have the virtual particles. If they combine together, they release some amount of energy. But if they are being separated by the event horizon, those virtual particles are being separated. That means some amount of matter is releasing out from the black hole. Now, how much matter has been removing out? How much energy has been releasing out? That we can say as, for a mass of an asteroid, it releases a 20 centigrade of energy. But for a mass of a mountain, it releases more amount of energy, that it decreases the black hole, and one day it will be collapse. So but that doesn't happen, as it takes Google years to complete it. and to get the destroy of a black hole. For suppose if you take a boiling water and when the water boils up, you feel the water vapors coming out, that the heat energy in the form of water vapors coming out. The same as for the Hawking radiation, as the whole we have the denser particles, so some of the virtual particles escape out from the black hole, and if it makes continuously, so it takes more than billion of years, and for every day it takes minus 0.00001% of mass, and it takes a more millions of years of billions of years and billions of years to complete the whole particles out. And if it continuously out, one day the black hole will become old, very old, and it's going to be collapse and get destroyed. But if the black hole is being destroyed, then what happened to the universe? The information is no longer available. Now, what is an information? So, information is the atoms or particles which are being arranged in a particular form or perfect form. So, for example, if we take a carbon atom and if they have been arranged, we get a graphite. And again, if they have been rearranged, we get the information of a diamond. So, graphite and diamond are the both particular information but with different arrangement structures. So, the atoms are the basic building elements over here, and if they have been arranged in a particular form, we get the different information. So atoms, which are the basic building of the elements, are being present in each and every element and each and every matter present around us. But once if they are being destroyed of arrangement, we cannot get it back. But according to quantum mechanics, quantum field, the information is indestructible. That means the information is permanent. For example, if you burn a piece of paper, so the each and every atom, the molecule, the particles, you have to be collected it, and again you need to rearrange it back, and you get the data which has been lost. But it is impossible as to arrange it back because the matter escapes around the universe. The same also in each and every particle, each and every matter present in this universe has the information about the universe which is from starting from the Big Bang. But once when it is been entered into the black hole, the information is cannot be retrieved. That means the information is been collapsed inside. So anything which is present around the black hole, it takes up and destroys the information and make it as singular particles. So all the matter holds the complete information about the universe, but once if they are been entered into the black hole, it makes an unknown information which cannot be identified. In general relativity, a white hole is a hypothetical region of space-time and singularity which cannot be entered from the outside, although energy, matter and light can escape from it. So what we can say is it is just like the reverse of a black hole. So anything which goes into the black hole pushes down into the singularity, but the white hole, anything which moves in front of it, it pushes away from it. So these white holes and black holes are quite opposite to each other, just like a matter and antimatter, and a particle and antiparticle, just like an electron which has its antiparticle called positron. So they act as the opposite like black hole and white hole. So I think they act as a wormhole or a roasting beach to move from one place to another place, or it could be used to travel from one universe to another universe. Anything which goes into the black hole should come out, so that way could be a white hole, so it could be act as a bridge like a wormhole to move it from one space to another, or it could be a bridge to travel from one universe to another universe, that the parallel universe concept. And these black holes can rotate in a direction. So let us assume it is moving in a clockwise direction. So how it does it spin? So that spin has a particular thing, that when it was a star, so due to the huge explosion with a high velocity, the angular momentum makes it to rotate around itself and grab the information or the matter which is present around it and pushes down into the singularity. Now let's have a discussion of space-time fabric and also the gravitational waves. So to explain the space-time fabric, we have brain grind to explain about it as the 100th anniversary of the Einstein's general theory of relativity, and he is going to demonstrate that how the space looked like and how the planets and the massive objects revolve around each other. So that we have a demonstration, and over to brain grind, the the chairman of the World Science Festival.
100th anniversary of Einstein's general theory of relativity. So a little demonstration here at home to explain the essential ideas. So Einstein wants to know how the force of gravity works, how the sun communicates the pull of gravity across empty space to the Earth. Here's the idea he comes up with. He says that the fabric of space is nice and flat if there's nothing there, no stars, no planets, which would mean that if an object rolls through that environment, say this is a comet or a planet, it will go in a nice straight line trajectory. But the key thing is Einstein says that if we have a heavy, massive object like the sun, Einstein says that the sun, merely by being within the fabric of space, causes the fabric to curve, to warp. And then other objects, like the planets, the Earth, Mars, and so forth, he says, they go into orbit because they're rolling along the curved environment that the sun creates. This, according to Einstein, is how gravity is communicated from the sun to the Earth, to Mars, to the other planets. This is how gravity works. Now, we did a little version of this demonstration not too long ago on the Late Show with Stephen Colbert. We got a lot of really great response and a number of great questions were asked online. So let's answer the two most frequent questions that people asked. Okay, question number one, Alec.
Why isn't the Earth spiraling into the sun?
Yeah, exactly, right? When you look at the marbles, they're all spiraling into our yellow shot put here. So would that happen to the Earth? Why doesn't the Earth spiral into the sun? Well, the answer is these marbles are spiraling in because they're losing energy, because of their frictional interaction with the spandex. In empty space, there's virtually no friction at all, so planets hardly lose any energy. Now, they actually do lose a little bit because the planets can cause the fabric of space to ripple a little bit. We call it gravitational radiation. So if you were to wait about 10 to the 20 years, 100 billion years, if the Earth is still here, it will, in fact, spiral into the sun. Very good. Second question, Sophia.
Isn't it gravity that pulls the yellow thing down?
Yeah, right? So if you think about it, the reason why our yellow shot-put sun is causing the spandex to warp, it's because gravity is pulling on the shot-put, right? So we're kind of using gravity to explain gravity. But the key idea is that Einstein says that the sun, merely by virtue of being in space, causes the fabric of space to warp. That's the key idea at the heart of the general theory of relativity. All right, guys, so that's all for today from the Day Green Science Lab. Science at home?
Yo!
All right.
Thank you, Brian. Now let us move on to the discussion of the gravitational waves. So long billions, like 1.3 billions of years ago, so there were two black holes were about to collide each other, and they were been producing a large amount of gravitational waves. That is, the waves had been spent out throughout the whole universe. So the gravitational waves are the ripples in the space-time caused by some of the most violent and energetic process in the universe, and this was predicted by Albert Einstein in 1916 in his general theory of relativity. So these waves are being sent out throughout the universe, as these are being produced by the two massive black holes which are almost 30 times to each other, and these gravitational waves are being sent out throughout the corner of the universe, and it has been reached to the Earth after 1.3 billion years. and these gravitational waves makes this fraction of change of the earth, so that we cannot be observed it. But this observation was done by the LIGO, that is laser interferometer gravitational waves observator. So with the help of the laser light, they had find out and they had calculated these sensitive gravitational waves. So they have sent a gravitational waves into a partial screen, and they had been hit to the mirror, and they had been reflected back again. So these two mirrors are being set upon the 40 kilometers away to distance each other, and when these two laser eyes, when that been reflected back, so there is an interference pattern. So by adjusting the interference pattern, so we get the resultant wave, so that makes the proof of the gravitational waves, and that makes the measurement of the gravitational waves, the sensitivity of the gravitational waves. So here, so how can we find out that sensitivity is equals to the size of the proton? That means if we move on to the atom, and when we move on near to the proton, so here the proton, which is 1000 times less than the proton, so the small intersect, that is the small change in the proton, so that has been calculated by the gravitational, that is the LIGO experiment. Now let us hear the gravitational wave sound. So listen carefully, use the headphones so you can clean it, you listen it very carefully. So we have a real picture of a black hole. So it was been taken on last year, that is April 10th 2019, so by the Event Horizon telescope, and this black hole is nearly 50 million light years away from our galaxy. So a galaxy where it has an elliptical shape. So in that galaxy, the center of the galaxy, they had found out this black hole, and this black hole they had named it as Missile 87. So Missile 87, also it has been named as M87, and this is the picture of the black hole. So black hole, I'm going to provide you the pic also here, and this black hole is nearly 50 millions of light year. So what is a light year? So light year is, we already know that the light travels with a speed of 3 lakh kilometers per second. But if we take it for a whole year, so it travels a distance of 9.4 into 10 to the power of 12 kilometers. So that much distance it will travel for a year. The light will travel for a year of 9.4 into 10 to the power of 12 kilometers. And if we multiply it with 50 million, so it is very far away from us. So about 50 million light years from our galaxy, that is from our planet. So we have a M87 black hole, and it has been captured by an Event Horizon telescope, and I'm going to provide you the picture of it. And I hope the upcoming science and technology will provide more information about the universe, and also they are ready to reveal the secrets of the universe. So now here we are with the final conclusion of our episode. So we have discussed about the black hole, the formation of black hole, how it is formed by the nuclear fusion, by the explosion, and if it is a massive body, then it turns into a black hole. and we have seen the different parts of the black hole, the singularity and the event horizon, the photon sphere, the ergosphere. We have seen the different parts of it, and we have discussed what happens if we move into the black hole. So just like what you have seen in the Interstellar movie, the clip, so you cannot move into the directly into another dimension, but might be possible, but it's not practically proven, or nobody has went inside it and make some experiments upon it. So it's just a theory. So it might be, we might be going to another dimensional world, or otherwise our body may tear up as there is strong gravitation field. Our cells will be torn up over there. So but we don't know what's going to happen when we move into the black hole. And we have discussed about the quite opposite of the black hole, that is anti-black hole, what we call as the white holes. So white hole is a hypothetical concept. So no one has a theory about it, the white hole, and no one has a definite proof of it. So Stephen Hawking had brought a proof with the Hawking radiation, the formula, and Albert Einstein, Stephen Hawking had made much more experiments upon they conducted several theoreticals upon the black holes. But white holes are still a hypothetical theory. So why they brought a theory of this white hole? Because if there is a black hole which is moving inside, then definitely there would be a anti-black hole which is in white in color and pushes outside. And white hole, black hole are connected towards each other, and they work like as a wormhole. So for example, this is a black hole and this is a white hole. So it could be a gateway to move it from one place to another place in a universe, or otherwise it could be used to travel from one universe to another universe. For suppose the two different universes we have, and we have a concept of parallel universe that will be done in another episode. So we have two universes, and to move from one universe to another universe we need a hole, wormhole, or you can teleport from one universe to another. But the concept what most of the scientists are thinking that is, so black hole and wormhole, black hole and a white hole together form a wormhole, and that wormhole could be a gateway to the two universes, or it could be a short way to travel in a space like millions of distance or millions of light years. So it could be a wormhole also. And we have discussed about the space-time fabric, and we have discussed about the gravitational waves. So the main purpose of the gravitational waves is to detect the property of the particle, and also to find out the formation of the universe. So millions or 1.3 billions of years ago, the two black holes collided each other and they combined to form a supermassive black hole. So due to that, when they both combine together, a huge amount of energy has been released. So that energy has been spread out in the form of gravitational waves throughout the whole universe. So these gravitational waves are being spread out throughout the whole universe, where the electromagnetic radiation cannot travel, but these gravitational waves can travel throughout the whole universe, and it has taken up 1.3 billion years to reach for us. And by using of this, they can be detect the nature, the property of the universe, and the atomic particles also. So this is what we have discussed in our today's episode about the black hole, the white holes, and we have discussed about the space-time fabric, and we discussed about the gravitational waves. And please subscribe the channel if you like it, and share it to your friends. Let's gain the knowledge. And what do you think about the black hole and white holes? Do you think they are the wormholes, or they are be connected to another universe? So give your valuable comment. Let us discuss the concept of black holes, the white holes, and also let us discuss about the gravitational waves. Thank you one and all for watching the video. Subscribe and share it to your friends.